Assalamualaikum warahmatullahi wabarakatuh. I am Ismahani from Zafis Group. Today I would like to present our case study outline. Our case study outline title is Refining Process in Cooking Oil Production. So what is refining process? Refining process is a set of process or treatment that is necessary to turn vegetable raw oil into edible oil or cooking oil. The first stage of refining process is degumming. Degumming is to remove phospholipid from crude oil. The second stage is neutralization. Neutralization is to remove free fatty acid that responsible for off flavor and lower the oil shelf life. And the third stage is bleaching. In bleaching process involve remove the pigment like carotenoid and chlorophyll and other impurities that mainly trace metal and product of oxidation to improve oil color and stability. And next stage is deodorization. Deodorization is the process to remove odoriferous compound aldehyde and cetanoid so that the refining oil flavor and odor are neutral. The next stage is winterization. Winterization is used to remove wax from the oil. So the next part is I would like to explain the related parameter in cooking oil refining. The most critical parameter is temperature parameter and the other key parameter are pressure and flow rate. In control the temperature parameter, globe valve offer very high accuracy temperature control across the various processes involved in the refineries. These valves are suitable for flow stream control, particularly where temperature is supposed to be held constant, especially in those processes where it is necessary to adjust the temperature accurately. Globe control the stream of heating or cooling media at each stage of refinery to ensure all terminate stage at each the most favorable condition to optimize efficiency and quality the refining process. Next, the other key parameter that will impact the refining process is pressure and flow rate. Pressure is important in stages such as deodorization, which involve steam distillation under vacuum condition. The flow rate influences consistency and effectiveness in refining since it's a low homogeneous oil treatment. The system works with technologies such as flow meter and globe valve to ensure perfect condition throughout the refining process.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahid bin Matsani. My matrix number 1211058. I will present to you about the formula and specific characteristics for the globe buff. So, as my reading and as my overview, uh, the formula related with the globe buff is related with the temperature. So, the formula temperature with pressure because it's a microfluidic. Uh, the formula is about P1 over T1 equals to P2 over T2. So, but the specific formula for the globe valve is not we cannot determine it. For the specific characteristics for the globe valve has many, but I will take the several main part for the globe valve. So we have a bonnet, we have a stem function, we have a packing material, we have a seat ring, we have these characteristics. So the first part is about the bonnet. So the bonnet is provides access to the internal workings. It contains packing material to seal around the stem and prevent leaks. So, bahasa mudah dia, bonnet ni dia menyerapkan daripada sebarang kebocoran pada valve tu. Okay, so the stem function. Stem function connects the disc to the actuator, handwheel, or automated device. Rotating the stem raises or lowers the disc to adjust flow. It's typically made of strength steel. So, stem function ni lebih kurang dia macam alat untuk penggerak kepada globe valve tu. So, and dia connect dengan actuator. So, next, it's about packing material. Packing material located within the bonnet creates a tight seal around the stem made of graphite, Teflon, and braided metallic rings, prevents water from leaking from the valve body. So, bahasa mudah dia, packing material dengan bonnet ni adalah satu gabungan yang dua-dua function dia adalah sama untuk mengelakkan apa-apa sebarang kebocoran cecair ataupun air lah. Okay, so next is about seed ring. Seed ring ni form a tight seal against the disc when closed, made of wear-resistant materials such as stainless steel or specialized alloys, essential for leak-proof, shut-off, and minimizing maintenance. So, seed ring ni lebih kurang macam uh, apa-apa kebocoran dia akan detect dulu. Dia akan proof dulu. So, dia akan seal against the disc when closed. So, lebih, maksudnya fluid dalam valve tu lebih secure lah maksudnya. Okay. So, the last part is about a disc characteristics. It's a movable piece within the body that regulates flow, made of metal, plastic, or rubber. Common design, linear for proportional flow, equal percentage for accurate control, and quick opening for instant operation. So, this characteristic ni adalah benda yang bergerak, dia mengawal uh, uh, pergerakan cecair di dalam valve. Okay. That's all for me. Thank you.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Sidratul Family Saiful. My metric number is 121067. So, in this section, I will discuss and explain a little bit about two types of globe valve, which is T pattern globe valve and also Y pattern globe valve. So, they actually bring the same function but a little bit different properties. So guys, why the Y pattern globe valve was named as Y pattern? This is because of the features of the body itself, which brings the shape of Y, where the stem and the seed was placed and designed 45 degrees approximately with the flowing fluid. And this is to reduce the pressure drop and also the resistance. Same goes to the T pattern globe design, where the T pattern itself taken from the features of the body of the globe, where the stem is designed perpendicularly with the flowing fluid that brings the shape of T. The stem and the disc move perpendicularly with the flowing of fluid, which can provide the capabilities to the effective of shut-off. So, the grip pattern that will be used in our industry, which refining oil process machine, is Y pattern. Why? Because of the features of the body itself. Imagine, in refining oil process, there will be exist 4 or more tanks that will conduct a different temperature in each tanks. So, in order to bring or to flow the fluid in a very suitable pressure and temperature inside the tank, is to choose the right features of the body. So the Y pattern can reduce the pressure loss and also it can reduce the turbulence and offers excellent throttling capabilities that making it precise and suitable for flow regulation.
Moving on to the next part, which is materials used. The current materials used for globe valve in pump or refining processes are stainless steel. Stainless steel globe valves are widely used due to their excellent corrosion resistance, which is crucial for handling the aggressive media found in pump oil refining. Stainless steel globe valve can stand temperatures up to 1000 Fahrenheit, and also pressure up to 300 Pascal depending on the specific lot. Second is forged steel. Forged steel clock valves are also commonly used in pump or refining applications that require high pressure and high temperature capabilities. Forged steel offers superior strength and durability compared to other materials, allowing it to withstand temperature up to 150 Fahrenheit and also pressure exceeding 600 Pascal. The third is the FTFE, Teflon, and RTFE, reinforced FTFE. These materials are preferred for the seat components in globe valves used in pump oil refining. FTFE provides excellent chemical resistance and low friction, making it suitable for non-abrasive fluids, while RTFE improves wear resistance compared to virgin FTFE for slightly abrasive fluids. Next is the upgraded materials that we suggest for globe valves in pump or refining processes. First is the Hastelloy and Monel. These specific alloy materials are even greater than the stainless steel for the corrosion resistance, making them suitable for the most aggressive and corrosive environments found in pump oil refining. Hastelloy ammonia can withstand higher temperatures and pressure than stainless steel, providing enhanced durability and reliability. Second is the ceramic. Ceramic globe valve components such as disc and seat are an upgraded option that provides exceptional wear resistance and corrosion protection. Ceramic materials can withstand high temperatures and pressures while maintaining their integrity, making them ideal for demanding pump oil refining applications. Next is the cost comparison. Stainless steel and forged steel globe valves are generally more cost effective than the upgraded Hastelloy, Monel, and ceramic options. The upgraded materials such as Hastelloy and Monel can be 2 to 3 times more expensive than the standard stainless steel globe valve. Ceramic components can also be significantly more expensive than traditional metal valve parts. Next is the advantages of upgrading to Hastelloy, Monel, and ceramic materials. First is to improve corrosion resistance, allowing for longer service life and reduced maintenance costs. Second, the ability to withstand higher temperatures and pressures, enhancing the valve performance and reliability in the demanding pump oil refining environment. Third is to reduce risks of valve failure and leaks, improving overall process safety and reducing the potential for product contamination. Fourth is the enhanced durability and wear resistance, leading to fewer valve replacement and downtime. Fifth is the potential for increased process efficiency and productivity due to the improved performance and reliability of the upgraded globe valve. As the conclusion, the choice between the current upgraded materials for globe valves in pump or refining processes will depend on factors such as the specific operating conditions, the aggressiveness of the media, the required temperature and pressure ratings, and the overall budget and cost consideration. While the upgraded materials offer superior performance, the increased cost may not always justify the investment, especially in less demanding applications.
So next, I will explain a little bit about the implementation plan of the refining process of cooking oil using palm oil. So the first step that we have to implement in this process is the quality assessment. In this quality assessment, we have to measure FFA, which is the free fatty acid, phosphatides, oxidation products, metal traces, carotene, sterol, tocopherol or tosotrinol, and DOBI, which is the degradation of bleachability index. This parameter is what we have to measure to get the quality oil. So to ensure that the oil in a good quality, we have to ensure that the free fatty acid is less than 3%, the phosphatides less than 5 ppm, the PV, which is the peroxide value, is more or with equal or less than 4, the NV, which is the antecedent value, is less than 4, iron less than 3 ppm, copper less than 0.1 ppm, and carotene in the range 500 until 2000 ppm. So if we get this value, and we will get the good quality of oil. So and then we move to the another step, next step, which is the process selection. In this process selection, actually refining process has two type of process, which is the physical refining and chemical refining. But in this to get the quality cooking oil, we have to choose the physical refining because it is preferred for the high acidity oils. So we move to the next step when we choose the physical refining process. So the first step in this physical refining process is degumming. Degumming is actually when we have to in this process, degumming process, we have to use water, wet acid, or dry degumming with phosphoric or citric acid to remove the phosphatides. Okay, so to remove the phosphatides. In the next step, which is the bleaching process, we have to implement single stage or multi-stage bleaching using bleaching earths. And so this process is actually to optimize the temperature, the humidity, and bleaching earth type, because actually in this process we have to control the temperature, the humidity to get the good cooking oil. And then to minimize the loss of desirable component, which is the tocopherols or the tosotrenols, we have to go to the next step, which is the deodorization. So in this process, we use the vacuum steam stripping at high temperature um, to remove the flammable and odoriferous substance, which is the tocopherols and tosotrenols. So in this process, we have to control the temperature, the pressure, and steam injection to retain the tocopherols and tosotrenols in the cooking oil. So in this refining process, we use the valve in the degumming, in the bleaching, and the deodorization process. In this process, this process connected to each other with the valve. So we want what so back to our objective. We want to change the material of the valve, but we still use globe valve. So next, I will pass to the next presenter. So that's all from us. Thank you for listening.